Hello everyone, welcome to channel IGCSE and GCSE Maths School. Today a fine maths problem. Let's see what is this fine maths problem here. If A equals B minus C divided by D minus M, where B equals 46, C equals 37, D equals 22, M equals 19, all correct root significant figures. Find number one, upper bound and lower bound of A to range of values of A. Let's start. Okay. Right, this is the question. They say that A equals B minus C divided by D minus M. Right, in this place, now we are going to find the upper bound and lower bound of A. This is a caution. This is a caution because this equation says divide B minus C whole thing by D minus M whole thing. This means division. This can be going this way also, like B minus C. This is divided by D minus M. This you by using the division sign. Without using the division sign in fractional form, we can write in this way. That is B minus C divided by D minus M, right? This is one another way of writing the same thing, right? Okay, what it is. We will go to write the question. Give me 1 second. Okay, let's erase this part. Right, okay, let's start this. Now, you must treat this as a division of two statements. This is one statement, that statement is divided by this statement. This numerator, this is denominator. Otherwise, this is called dividend. What is called? Dividend. So, this is called what? Divisor. What is that? Divisor. Divisor. That's called divisor. Right. This is called divisor. This is called divisor. Divisor. This is called dividend. 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 Right. Okay. Now here, this division statement, when you come to the upper bound and lower bound of division, then upper bound of division, we have learned that formula for finding the upper bound of quotient. Then quotient is the answer of division of two numbers. Now, one number divided by the other number. Otherwise, the quotient is the term used to name the answer after dividing one number by another number. Quotient is the answer of one number divided by the other, right? Don't write. Okay, then this is here. Then this quotient divided this statement, this value, this dividend value is to be divided by this divisor, right? Then this is the quotient. Therefore, A is the quotient. A is the answer of dividing, answer after dividing D minus C by D minus M. So therefore, A is the answer of division. Therefore, A is the quotient. Therefore, now what applies here is the principles of finding upper bound and lower bound of a quotient. Upper bound and lower bound of quotient. What is the formula for find the upper bound of quotient? That is, upper bound of quotient equals upper bound of the dividend divided by lower bound of the divisor. Upper bound of the dividend divided by lower bound of the divisor. Upper bound of the top part divided by the lower bound of this divisor. Therefore, upper bound of A equals upper bound of B minus C divided by lower bound of D minus M. Right, okay. Now we'll write it then. Upper bound of A equals upper bound of B minus C, then divided by lower bound of button D minus M, right? Okay, now this is the lower bound of A. That is the formula for finding the upper bound of A, upper bound of quotient A. Then how do we find, what is the formula for finding the lower bound of quotient A? How do we find the lower bound of the quotient? Lower bound of quotient equals lower bound of the dividend divided by the upper bound of the divisor. Then lower bound of a quotient equals lower bound of the dividend divided by upper bound of the divisor. Right, now we can write that also. Then that is lower bound of A equals, therefore, lower bound of B minus C divided by upper bound of D minus M. Lower bound of what? B minus C divided by upper bound of what? Divisor, that is what? D minus M. Right. Now here we have got two things. Now we need to find four pieces of information to find the upper bound and lower bound of A. Then you want to find the upper bound of B minus C and lower bound of B minus C. Then you have to find what? Lower bound of D minus M and upper bound of D minus M, and substitute those values as data into this formula and get the lower bound and upper bound of it. After find the upper bound and lower bound of the A, it's very easy to write the range of actual values of A. Therefore, now we'll first of all find the upper bound and lower bound of B minus C, right? Then you here write B minus C, this is workings, right? Okay, your upper bound and lower bound. Upper bound, if I first write upper bound of B minus C, right? How much? How do you find? Then this is when you come to upper bound of B minus C, that is upper bound of a difference. Upper bound of a difference. B minus C gives the difference. Upper bound of a difference of two corrected values, right? Then how do you find the upper bound of two corrected? What is the formula for finding the upper bound of a difference? We have learned that formula in our previous videos. You can go to those relevant videos and watch there in the playlist called rounding of numbers and upper bound and lower bound corrected values. Rounding of numbers and upper bound and lower bound of corrected values. That is the title of the playlist under which all these comes. Then go to the playlist and find the relevant video and watch. That is the title of the video must be upper bound and lower bound of difference. Otherwise, finding upper bound and lower bound of difference. Right. Okay. Now I will come to this one. Right. We'll see upper bound of, how to find the upper bound of difference. Upper bound of a difference equals upper bound of the larger value minus lower bound of the smaller value. Then here the large value is B. Now C is to be deducted from B because it is possible to be, because C is possible to be divided. C is to be subtracted from B. I'm sorry. C is to be subtracted from B. That means the B is the large value, C is the smaller value. Then what is the formula for upper bound of B minus C? That is upper bound of the large value minus lower bound of the smaller value. Here the upper bound of B minus, that means lower bound of C. Therefore, we write upper bound of what? B minus lower bound of what? C. Okay, that is it. Then we'll find the upper bound of B. Upper bound of the upper bound of single corrected value. So we have given you the formula at the very beginning of this series of videos of rounding off and upper bound and lower bound of corrected values. Now go to that video and see. We have learned formula like this to find the upper bound of single corrected value. That is corrected value. Upper bound of single corrected value equals corrected value plus degree of accuracy over 2. Corrected value plus degree of accuracy over 2. Then corrected value of B. Then write corrected value of B plus what? B plus degree of accuracy over what? 2. So that is how do you find the upper bound of, then minus, the other one is what? Lower bound of C. What is the, how do you find the lower bound of single corrected value? Lower bound of C is a single corrected value. Then we have learned the formula for find lower bound of single corrected value. General formula is lower bound of single corrected value is corrected value minus degree of accuracy over 2. Then here lower bound of C is corrected value of C minus degree of accuracy over 2, right? Okay, now we'll find that. Okay, corrected value of B has been given. How much? correct 46 substitute here, 46 plus. Then degree of accuracy over to what is the degree of accuracy? Correct two significant figures. Come two significant figures. This is the first significant figure. Significant figures are counted from left end of the number. We have done interesting video on how to identify significant figures and how they are counted. And that's when you go to that particular video, we have done a separate video in that same playlist, rounding of numbers and upper bound and lower bound. Then go to that playlist and find the long video and watch that. Then you have good knowledge of significant figures. Right, the significant figures are counted from the left side. This is the first significant figure, second significant 6. Then to get the degree of accuracy relevant to the be applied in the upper bound and lower bound formula, you have to get the place value of the significant figure, first, second significant figure, particular significant figure. That this has been written correct to second significant figure. Therefore, go to the second significant figure, first one, second one. Then get the place value. This place value is units here. Units tens. This one units means degree of accuracy is 1. Then 1 over 2. Then minus. Then corrected value of C. Corrected value of C is 37. 37 plus minus degree of accuracy of 2. What is the degree of accuracy? What is the degree of accuracy of C? That is also corrected to step 2 step means here first significant figure, second significant. But then this is also units here. That second significant figure is the unit, is in the units place. Therefore, degree of accuracy to be used in the upper bound and lower bound formula is unit value, that is 1. Okay, now right here 46.5 here, 46 plus half, then minus 37 minus half is 36.5. No? Our answer will be how much? 10. This is the upper bound of B, and then we'll find the lower bound of B minus C also. Lower bound of what? B minus C. What is the lower bound of B minus C? Then lower bound of difference again. What? Lower bound of difference is, we have learned a formula 4 lower bound of difference, that is lower bound of the larger value minus upper bound of the smaller value. Lower bound of the larger value minus upper bound of the smaller value. Lower bound of a larger value minus upper bound of the smaller value. Here the larger value is B. It's lower bound, you have to take lower bound of what? B, then minus upper bound of C. That is how to find the lower bound of difference. Then here you get again the lower bound of B equals how much? That is the finding lower bound of a single corrected value. Then to find the lower bound single corrected value, the formula is what? Lower bound equals corrected value minus degree of accuracy over 2. Lower bound equals what? Corrected value of B minus degree of accuracy over 2. That is this one. Then this one is what? Upper bound of upper bound of C. Upper bound of C means upper bound of single corrected value. Upper bound of single corrected value. How do you find the upper bound of single corrected? That is formula. The general formula applies. That is corrected value minus degree of accuracy over 2. Here corrected value minus. Upper bound of single corrected value, upper bound plus degree of accuracy over 2. Therefore, the upper bound of C is corrected value of C plus degree of accuracy over 2. Upper bound of C is how much? It is given 37. What is that? 37. Then plus degree of accuracy, that is the upper bound that should be taken here. Then it is 37 plus half. Then we will upper bound here will be then upper bound of C means corrected value of C plus degree of accuracy over 2. Degree of accuracy over 2. So that is the formula, right? Then we will okay. Then we will take corrected value of B. Corrected value of B is given at is 46 here, minus degree of accuracy as usual in finding upper bound of B minus C. We use here second this correct to 2 significant, second significant 6. That is in the unit place. Therefore 1 over 2. Degree of accuracy 1 to be taken in the to find the upper bound and lower bound. That is 1 over 2. Then minus corrected value of C. Corrected value of C is 32, 37. 37 plus degree of accuracy over 2. Here also correct two significant figures. Second significant figure is here. Plus 1, second one. Therefore, this is unique place. Therefore, also here degree of accuracy to be applied in the upper bound and lower bound formula is 1. 1 no 2 because the correct degree of accuracy is the two significant figures. The second significant figure is the unit value. When it is second significant figure is in the unit place, the degree of accuracy to be used here 1, right? Okay. That has been discussed in detail in one of the previous videos. Significance, how to find upper bound and lower bound of numbers corrected to significant figures. There's a special video. Go and watch that. You will get a very good understanding of how to choose the degree of accuracy to be applied in upper bound and lower bound formula when the numbers have been given corrected to significant figures, right? Okay, now come to this one. The 46 minus half is 45.5. Then minus 37.5 means 37.5. How much is this? This one will be 45.5, 37.5, then 45.5. 37.5, 2.5, then 5.5. How much is it? 5 goes, then here you get 15, then 8. 8 is left. The answer is 8. Right. Then lower bound of b minus c is how much? 8. Lower bound of b minus c is how much? That is 8. Now you go to b minus m. Then b minus m. We will see. Then upper bound. Upper bound of d minus m. We need upper bound of d minus m. Right. We will find that. Then how much upper bound of d minus? Again, upper bound of difference we know from this one. Upper bound of the large value minus lower bound is smaller value. Therefore, upper bound of what? D minus lower bound of what? M. So that is upper bound. The upper bound of D is how much? Upper bound of D is there's the upper bound of single corrected value. Then general formula applies. That is corrected value plus degree of accuracy over 2. Then here corrected value plus degree of accuracy over 2. Corrected value of what? D plus degree of accuracy over 2 minus here how much? Lower bound of m is how much? General formula applies. That is general lower bound of single corrected value. That is corrected value minus degree of accuracy over 2. The lower bound of m is corrected value of m minus degree of accuracy of m. The corrected value of m is how much? Corrected value of m minus degree of accuracy over 2. Right. Okay. Then we will write here substitute. Then corrected value of d. What is that? The corrected value is 22. That is 22. That is 22 plus. Right. That is 22 plus. Right. And right. 22 plus degree of accuracy here of m. Sorry, degree of accuracy of d is how much? Then that is correct to two significant figures. Again, two significant figures. First one, second one. Here the unit value 1 over 2. 1 is the degree of accuracy that to be applied in finding upper bound and lower bound. Then minus corrected value of m. Corrected value of m is 19 given. It's written here. Then minus degree of accuracy. They are also correct to two significant figures here. 1, 2. So in the unit place, therefore degree of accuracy is 1. 1 over. Right. Now write here. Then calculate 22 plus half is 22.5. Then minus 19 minus half 18.5. 18.5. 18.5. Then what is the answer? Answer will be 22.5 minus 19.5. That means 20, 21, 23. Right? Is it? Sorry, here I have made a mistake. So mistake right, 19 minus half is 18 here, sorry. This 18.5. 18.5 means here 18, 19, 20, 20, and 22. That means 4. This is 4. Then D minus M upper bound, lower bound. Lower bound of what? D minus M. Lower bound of d minus, what is the formula for find lower bound of difference? Lower bound of difference formula, how much? Lower bound of difference formula is lower bound of the larger value minus upper bound of the smaller value. Here, therefore, this one lower bound of the b d minus m equals lower bound of d minus upper bound of m. Lower bound of d minus upper bound of how much? M. All right. Then lower bound of D. Lower bound of D, how much? Single corrected value. Then that means corrected value of D, lower bound minus degree of accuracy over 2. Then upper bound of M equals corrected value of M minus degree, plus degree of accuracy over 2, right? How do you find upper bound of single corrected value? Now, corrected value of D is how much it is given. It substitute 22. Then 22 minus degree of accuracy over 2, that is correct to significant figure. The correct significant figure, therefore, second significant figure is in the unit place, therefore, degree of accuracy is 1. Then minus 1 over 2 minus. Then corrected value of M. Corrected value of M is 19 again. Then plus degree of accuracy is how much? That is correct two significant figures. Here the second significant figure, that is unit place. Therefore again 1 over 2. Right. Okay. Then how much? 22 and 19 21. Sorry, 21.5 minus how much? 19 plus half means 19.5. 19.5. Then answer will be how much? 21.5 minus 19.5 means how much? That is 19.5, 20.5, 21.5 means 2. Correct, right? Yes. Okay. Now we substitute. We have all necessary essential information to be substituted into this one. Then we will write what is that? This is the first part of the answer, right? Then this is right. First part, upper bound of A equals upper bound of B minus upper bound of B on this 10. Then divided by lower bound of D minus M. What is lower bound of D minus M? Lower bound of D minus M 2. Divide equals 5. That is upper bound of A. This is what the lower bound of A. Lower bound of B minus C. What is lower bound of B minus C? Lower bound of B minus this one. How much? 8. Then what upper bound of D minus M? What is the upper bound of D minus M? This one. Upper bound of D minus M. How much? 4. The answer is 2. Right. Then that is the first part. Upper bound, lower bound of A. Then the quotient has been found. Now we are going to find the other one, second one, range of actual values of it. That is range or actual is always lower bound less than or equals actual value of A less than upper bound. You write here. What is the lower bound here? Lower bound is 2. Then write 2 less than or equals. What is the actual value of A less than how much? That is the upper bound. This is the answer. Now write. Okay. The whole question has been answered. Yeah. Then watch the video again and again. Try to understand. If you find it difficult to understand, again write in the comment section. I will explain again it. Have a nice time. I finished the video itself, expecting to post another interesting video next day. Have a nice time. Thank you.